In analyzing data, we talked about something called measures of central tendency. We're now going to talk about some measures of variation. And we've actually talked about some measures of variation when we talked about the quartiles or the range, the interquartile ranges. Those were called measures of variation. Two particular measures of variation we're going to talk about are called variance and standard deviation. And they're going to require some formulas that I would be more than happy to give you on a test. You just need to understand how to use them. So, when we're finding variance and standard deviation, the first thing that you would always find is the mean. And we use this notation for mean, which is an average, and it's pronounced x bar. So when I say find x bar, you're going to find the mean of your data. The next thing that you're going to do is you're going to find the difference between x and x bar. In other words, you're going to take every value in your data and you're going to subtract it by that number you got for the mean. And this is probably going to be best done making a table, so you'll see an example of this in a few. After you find all of those differences, I want you to square all those differences. Once we've done that, we're going to find the average mean of these squares. The average mean of these squares is called the variance. The variance, we use this symbol. This is the Greek letter sigma. It's a lowercase sigma. Because there's an uppercase sigma, we're going to run across in a moment. So sigma squared is going to be, this is our uppercase sigma. In mathematics, that funky symbol means to add. So it says add all the squares and divide that by the number of data points in your set of data. To find the standard deviation, all you have to do is take the square root of that answer. And I know this looks like a bunch of funky symbols, but when you see it all set up in a chart, it won't look so daunting. In order to learn how to find variance and standard deviation, we're going to start with a very simple set of data that only has 5 data points. So, what we're going to do with 6.9, 8.7, 7.6, 4.8, 9.0 is first we're going to find the mean. How do you find the mean? You add them, you divide by 5. Remember, divide or add all the numbers together first, then divide that answer by 5. You should get 7.4. All right, that's the mean. Now what I'm going to do is I'm going to make myself a little table. The little table that I'm going to make is going to be x, x bar, x minus x bar, and x minus x bar squared. And the reason I'm going to make this little table is because it's going to help organize my data. Hopefully I gave myself enough space. Alright, so I need 6.9, 8.7, 7.6, 4.8, 9.0. Look at that, I gave myself the perfect amount of space. Okay, so now that I know what the mean is, x bar is the mean, so it gets written in every cell in this little chart. The third column is x minus x bar, so 6.9 minus 7.4 is negative 0.5. 8.7 minus 7.4 is 1.3. 7.6 minus 7.4 is 0.2. 4.8 minus 7.4 is negative 2.6. And 9 minus 7.4 is 1.6. The fourth column is the square of all those differences. Remember, when you square a negative, it becomes a positive. So I should get 0.25, 1.69, 0.04, 6.76, and 2.56 when I square those. Now what I want to do is I want to find the sum of all the squares. When I add the 5 numbers in the last column together, I get 11.30. So now, in order to find the variance, which is the sum of all the differences squared divided by the number of terms in my data, the sum of all the squares is 11.30. I have 5 numbers. I'm going to get 2.26. That's the variance. And to find the standard deviation, all I have to do is take the square root of the square root of 2.26, which is going to be approximately 1.5. When dealing with larger sets of data, finding the variance in the standard deviation can be very daunting. In the previous example, I only had 5 numbers in my data set, so making a table was very easy. But this particular data set in problem 2 has 15 data points. That's a pretty big table. That's a lot of work. And the more work I have to do, the more likely I am to make a mistake. So there's a way to get the calculator to get all this information for you. So what I want you to do is the same thing we did when we analyzed data. We went and put this data into list 1 under stat. So if you go to stat and edit, we're going to put this data into list 1. Remember, you can clear list 1 by putting the cursor on list 1, hitting clear and down, and the data will go away. Make sure you have no data in any other list. Put these 15 numbers into your list. They do not need to be in order. Once you've typed them all in, then you're going to go back into stat, but this time you're going to arrow one to the right to calc, and you'll see option number 1 is called 1 var stats. It's called 1 variable stats. And if you hit enter, you should have a bunch of data pop up on the home screen. It should say this at the top, and then it should say X bar is 17.6. That's nice because it's the mean. And then it should say sigma X is 264. Don't worry about that. Sigma X squared is 4832. Again, don't worry about that. Sx is equal to 3.641035959. Ignore that. Do not ignore the next one. Sigma, little sigma x, 3.517574922. That's our standard deviation. And then it says n equals 15 because that's the number of data points, and then there's probably a down arrow, and there's more information. If you were to take advanced placement statistics, you may go look at some other information. So if you actually put this in the calculator, it'll tell you the mean, it'll tell you the standard deviation. Well, it didn't give me the variance. Well, that's okay. How do you find the variance? The variance is this squared. So if you take your 3.51 and you square it, you should just get the variance, which is approximately 12.32. So even though it didn't give it to you, you can find it very quickly by just taking the standard deviation and squaring it.